perspective, from a security perspective, they don't provide the same level of isolation as virtual machines. So if you want to separate, let's say, in a more safe way, different users of different slices of the system, then you can use virtual machines in production. And inside virtual machine, you can run containers, which is really what many times happens in reality. So, advantages of containers. More or less, we have already mentioned them, but the speed, no operating system to boot. Applications are online in seconds. So, according to some surveys, to boot a virtual machine, you need on average 5 minutes, 4 minutes. Of course, it depends on which operating system, which type of virtual machines. It can take from 1 minute or around 1 minute to some few minutes. With containers, you can do the same in seconds. So you change the order of magnitude. You have portability because you have a way to package all the dependency needed for the application, and this package can be easily transported among different execution environments because they are lightweight and because they contain all the dependencies by definition. And efficiency because they have less overhead compared to virtual machines. And also they can improve, if used together with virtual machines, they can improve the efficiency of using properly a virtual machine. So you can allocate, as I said, multiple processes in a single machines and use all the resources in the best way. So just to recap, given the goals that I mentioned at the beginning, well, containers basically achieve all of them. So efficient usage of resources. Again, you have the means to separate the execution of processes, allocate resources to each process, and these processes are isolated and they can help partitioning a hardware machine or a virtual machine. High flexibility in operations, programmable servers. Well, containers are still software, so you can easily program everything in containers. You can run multiple applications on the same hardware, and you have portability across environments. The negative part, as I mentioned, is worse isolation compared to virtual machines. One effort in this regard is unikernels. Unikernels are like in between virtual machines and containers because basically they provide the same level of isolation of virtual machines, but they don't include a fully fledged operating system, just the kernel. So it's a in-between technology, but at least for this talk and for most of the cases, isolation, given that we still have virtual machine, is not the killer feature. All the benefits that container brings are really key to cope with this need of speeds that is increasing over time. So just to mention some few concepts of a container, here I mentioned Docker because it's one of the most important technology, but the same concepts can be applied, or similar concepts can be applied to other container engines. So in containers, you have still the same idea of virtual machines. So you start from a blueprint that is called the image, where you define that is basically a file, a snapshot, where all the dependencies and the application code is stored. And for containers, you have infrastructure as code, so a dedicated language to define which are the dependencies to be included in the image. Then you have a container that is an instance, a living instance of an image of a container. So for example, you can have a single image that is the microservice one of your application, and then you can have multiple instances of microservice one as containers. You have the engine, that is the software that execute the commands for creating the containers, changing the resources dedicated to the container, changing the volumes attached to the containers, so which folder of the host operating system can access the container, and so on. Then you have a very important concept that is the registry. The registry is usually public, but it could be private, repository where all the images of containers are stored. So of course, if it's public, okay, you have many images from different stakeholders, while if you have a private registry, you will have all the images of your company, say. And then you may have a control panel where you basically, you can manage containers and their orchestration. So I hope that I explained why containers are key for modern deployments. But as you know, this field is progressing extremely fast, so there are already next steps. So an in-between step is container orchestration, because as far as we discussed right now, basically we didn't talk on how different containers can communicate with one another. So it's not realistic to think that with a single physical machine or a single virtual machine, you can deploy a full system. You usually have a cluster of machines, could be physical, could be virtual, could be mixed. And then you need a software that helps in managing the containers. For example, creating a virtualized network across all the different machines. So in this regard, there are tools called orchestrators that manage actually multiple containers running on a cluster of machines. Orchestrators provide networking, also monitoring, runtime management, also scaling. And they do by using high-level concepts. So user can think in terms of, for example, services, deployments, this very high-level concepts. And two main tools that are very popular nowadays are Kubernetes by Google and Docker Swarm, that is an extension of the Docker engine that allows for orchestration. And between the explosion of containers in the market and their actual birth, some in between, let's say, so in this midterm, basically what users were doing was to, as I explained, install manually on virtual machines in the cloud, the Docker engine or the container engine, and operating on containers, let's say, manually. Then what happened is that cloud providers understood the importance of containers, and they started providing services dedicated to containers. So you are maybe familiar with AWS EC2, that is the cloud suite of Amazon Web Service. This is just an example. There is also Google Cloud, Azure, and others. And well, some few years ago, AWS presented the Elastic Container Service. So a service dedicated to the management of containers. So in few words, basically, containers, so the user of this service could use the concepts that I explain about containers, so container images, deployments, tasks in the case of this service, without the need of installing the Docker engine or the container engine in the virtual machine. So the idea is that they provide a container engine as a service or an orchestrators of a container as a service, and users should just only need to think in terms of container concepts. Behind the scene, actually, at least for the standard version of the Elastic Container Service, all the containers are still deployed on virtual machines. And this service was, of course, integrated with all the other services that the AWS suite provides, so security groups, elastic load balancing, and autoscaling. In a similar way, the Google Cloud Platform and Azure provided a similar service, but using a well-known orchestrator, while AWS created its own orchestrator and later added added Kubernetes. Google and Azure provide these tools, actually Kubernetes as a service. So instead of creating manually a cluster of virtual machine and then install Kubernetes on top and then on top running containers, what these cloud providers do is to provide an already an on-demand cluster of machine with Kubernetes installed, and users can just need to use Kubernetes as it was already installed. So that's the idea. So it's like Kubernetes as a service. Actually, as I said, also AWS provides right now Kubernetes as a service because it's a tool that it's very extendable. It's very easy to use and very powerful. So the adoption of Kubernetes is very important. And many people are right now calling Kubernetes the operating system of the cloud because it allows also to move among cloud providers very easily without having the vendor lock-in effect. Because if you use Kubernetes on Azure, then you can easily migrate to Google Cloud if you still use Kubernetes. And the same goes for AWS. So it's a very important tool, actually. So, but these are not really the next steps. They are just advancement and, let's say, awareness related to the containers and their importance. But the paradigm was more or less the same as before. So what could be, where we can improve from this point? Well, the main idea is that even if you use containers, you still have to take a lot of decisions. So you have to select your infrastructure as a service provider, so AWS, Azure, Google, the container engine, the container orchestrator, then a platform for monitoring, for logging, networking, storage, and of course, you have to pick an operating system as a base layer. So in the end, there are still a lot of tools to be selected. And to avoid this kind of mess, let's say, or say to decrease the complexity, a new paradigm is becoming very popular nowadays. That is serverless computing. And the name says it all. Basically, the idea is that you run applications on an infrastructure completely managed by third parties. So the idea is that we move from servers that we manually had to maintain, start and stop, very difficult to scale, very difficult to operate. Then we had virtual machines that are an incredible change of paradigm, probably between servers and virtual machine. I mean, this gap is the most important still. Then we have explained the limits of virtual machines, and then we have containers with all the benefits. They are lightweight, but still it's a very low-level concept compared to the application, because in the end, what you want is to have a very fast way to run your application at scale. So serverless is this next step. Users do not have to maintain the infrastructure. The infrastructure is not visible from the perspective of the user. You simply push your application and everything works automatically. So the application is scaled automatically by the, let's say, cloud provider, because still these approaches are related mostly to the cloud. So actually, serverless are more sophisticated than that. This is just the general idea. And as we will see, serverless and containers are strictly related, because the key enabler of serverless is container, with the main difference that instead of be the user, the one in charge of managing the containers, now it's a third-party company. So serverless bring a lot of advantages. So you don't have to manage the operations on the infrastructure, but also some complexity. As always, everything is a trade-off, right? So what's the point here? So a lot of behavior is moved to the front end, because you don't have, I mean, you can have server-side logic, but still you rely on different services. I will show you some examples. And sometimes you need to call different services, third-party services, from your front end instead of doing in the backend. So the need for always-on servers is removed. So the idea is that a company, if completely onboards serverless, this company doesn't need to have always-on servers. It has a provider that manages the infrastructure, but from the point of view of the company, there is no infrastructure at all. There is just an application running somewhere, and it's completely managed. And again, the goal is to reduce the operational cost and complexity that arise from this complex chart. So serverless is can be seen from two, let's say, it includes two different approaches. One is backend as a service, which means relying heavily on third-party services. For example, you have a database, you don't want to deploy a virtual machine or a container with a database, but you want a hosted database. So a database as a service, and use this database without knowing how it's deployed, the resources are located. You simply use it as a service, as I said, on demand. One popular example is Firebase, for example. Firebase is now was acquired by Google, and it provides a way to store data, and basically you pay for read and writes, and also for some storaging, but you don't know how many resources are allocated to your database. And the second one, and most important, is function as a service, or FaaS, where custom code run in ephemeral containers. So you can still have your custom logic, of course. It's not that all the logic is migrated to the front end, just part of it. You have function as a service. And the idea is that you upload to the cloud provider, to the serverless provider, your functions, which are like an extreme version of microservices. So instead of splitting your applications in microservices, you split applications in functions, which is an even finer grain partitioning. And these functions are executed in ephemeral containers, but still managed by the cloud provider, not managed by the user. We know that cloud providers use containers to run these services, but it's a detail, it's an implementation detail. We cannot access the way they manage containers if we use these kind of services. So in backend as a service apps, the application fully depend on third-party application services to manage for server-side logic and state. Another example is authentication. You don't want to implement your own authentication mechanism with your own virtual machines or container. You want to use it as a service. And then you have FAS, where the server logic is written by the app developer. It's a completely hosted service, and usually it's event triggered. And of course, these are not two isolated parts, but there is a lot of overlapping. So you can have, usually actually nowadays, an application is composed by some FAS and some BAS. And this is how it could appear if you want to visualize. So the traditional approach is that you have a client, you have your server. Imagine this to be an infrastructure, could be physical or virtual. You have your logic and you have your database deployed on your infrastructure, and these communicate in a very simple way. While with a serverless approach, of course, this is just an example. There could be different, let's say, types of architectures, but everything starts from the client that is more intelligent than this one. This one has only a single backend, and there is no complexity to deal with. Here you have the client that, for example, first called the BAS authentication service. Then it gets a response, then it uses another BAS service, a database as a service. We don't know these and these, how they are deployed. We don't know how many resources are allocated to them. We simply use it just to, in the case of a database, to read and write data. So we write some data on the product database, or we read some data from the product database, and then we can call, for example, our functions, so a search function or a purchase function that could be connected to another BAS database. So the idea is that we are moving from a very simple architecture to a more sophisticated one, with the advantage of not having to deal with a materialized infrastructure. Could have been virtual or physical. It's not important. Here we are beyond this idea. No serverless. So once again, all these components, I mean, we don't know how they are deployed. We don't know how are managed. We simply use them as a service. So here I have already explained. I will go a bit faster. One of the examples is AWS Lambda. I'm taking Amazon Web Services as an example, not because I'm a huge fan of Amazon Web Service or because they pay me something to do this advertising, but simply because it's the most important and most used cloud provider. And similarly, all the other providers nowadays have a similar offering. So the serverless service in AWS is called AWS Lambda, and the web page of AWS Lambda, just to give you a sense of what it provides, is AWS Lambda lets you run code without provisioning or managing servers. With Lambda, you can run code for virtually any type of application or back services, all with zero administration, and so on. So just one more bit on the fast architecture. So we have the client again. Usually you have a so-called API gateway that binds a REST endpoint to a function. You can connect function also to events. For example, I don't know, when a notification is received, you trigger the execution of a function, or to endpoints, as in this case. The most important part is that, and this is why I'm talking about this today, is that behind the scene, each function is executed on a pool of containers. If the pool is completely saturated, new containers are automatically created. We don't know how, we don't know how many, we don't know when. The cloud provider does these operations. We know that somehow this is happening, but we don't know, we don't have access. But we know that our application will scale proportionally to the demand. So the evolution of cloud platforms is depicted here. And we move from infrastructure as a service, where basically the user was, the starting point of the user was the operating system of the virtual machine, then container as a service, and then we have FaaS. In between, we have PaaS, that is platform as a service, which could be very similar to function as a service. The main difference between platform as a service, that is a very old concept, and FaaS, is that basically in platform as a service, you still have knowledge about the infrastructure, you still have control over how the infrastructure is scaled. With function as a service, you don't have any knowledge of the infrastructure, and you can't control how functions are scaled by the service, by the cloud provider. Another difference is that platform as a service are not as opinionated as function as a service services, because they do not impose a predefined structure of your application. While in function as a service, you have to split your applications in functions. You can easily deploy a monolith in platform as a service. With function as a service, it doesn't work. And one of the reasons is this. So functions are usually very lightweight. So functions are typically, and must be lightweight, because they are typically limited in how long each invocation is allowed to run. Functions are not allowed to run for longer than some few minutes. And if they do, they will be terminated. So this is a limitation from the cloud provider. Without this limitation, given that you don't have control over the infrastructure, without this limitation, you can have infinite billings. Because if in the worst case that something goes wrong, you are paying for each function execution, as I will explain in few slides. And if the execution is infinite, you pay an infinite amount of money. This never happens, everything has a timeout and so on, but this is a strict requirement of serverless services. Another problem is the cold start, because we don't know, as I said, how the containers that execute our functions are managed. You have to assume that these containers are created and terminated. Created and terminated, they are ephemeral by definition. This has a strong implication, is that you need to use technologies that are lightweight, because if your container contains a process that takes, for example, 10 minutes or 2 minutes to start, then if you send a request and there is no container ready, you have to wait behind the scene that the cloud provider starts a container, starts your project that takes minutes, and meanwhile you are waiting for an answer. And this is not a good quality. You don't provide a good quality of service. So the idea is that usually function as a service is strongly connected or used with lightweight technologies. So for example, the Java virtual machines and Java-based frameworks, which were very popular in the past, with functions, it's not that, it's not a good marriage, let's say, because typically a Java-based application is quite slow to start. Building. So here we are in the extreme, let's say, it's a very extreme version of on-demand building, because basically you pay for the time, the execution time. So if your request takes, let's say, 100 milliseconds to be executed, you pay for that 100 milliseconds. When no functions is under execution, you don't pay anything. If you have always on servers, could be again physical, virtual machine, you always pay something because you are using them. With serverless, you don't have this limitation. You pay only when the application is running, when the function is running. There are some, let's say, sophistications to the building model. I won't go into the details, but this is the main idea. Of course, the executions may be more expensive compared to if you take just the execution of the same execution on virtual machines, because here you are paying for all the operations that you are not that you are not dealing with. And from a billing perspective, purely billing perspective, it really depends for the type of workload that you have. If you have very inconsistent patterns, for example, where you have no requests for a lot of time and few requests or spikes, then function as a service could be very good, because when you don't have requests, you pay zero, and then you start paying only when you have these spikes. While if you have a constant workload, well, probably fast and function as a service, they are not convenient from a building perspective. They could be convenient for the perspective of operation management. You don't have to care about the security of the servers. You don't have to care about the updates, the management and the infrastructure, as shown here. So the pros of serverless are reduce operational cost, no infrastructural management, deployment, security, and you have a very fast time to market. You don't need to deal with all the decisions that I showed before, but you can simply, you have the application developed, you push it to the serverless service, and it's running. You have a public IP address, you have a public address to share, and it's running. You can connect your client in a few seconds without the need of managing the infrastructure. As cons, you have vendor lock-in, because a serverless platform typically is provided as is from a cloud provider. So changing the cloud provider is not that easy. You can have state in the serverless functions. Sorry about that. And as another weak point, let's say, you have more complexity in components integration and testing. Because of course, as we saw in the client, we have to deal with different components, some that are backend as a service, some that are functions, and you have to connect them. And testing is not that easy. So that concludes the, let's say, state of the art of the market. I don't know if I have time to briefly talk also about my research. If yes, I will be happy to do so. Otherwise, I have around 10 slides still. Otherwise, I mean, we can start a discussion.
Thank you, Giovanni. Hello?
Yes.
Yes, thank you. I was just checking, and I saw someone requesting to talk.
Okay, so
The
let me
stage
go
you
to.
can.
So I will
Yes.
skip this part, but I want to show you this because it took a lot of time. This.
Okay. Good. In Português, ok, that's good. Sim, creio que já temos o espaço para perguntas e respostas, como havia falado antes. Obviamente, não vou fazer nenhum resumo do que foi apresentado. Vamos ter coisas muito específicas, não é? E também não sou necessariamente especialista dessa área. Eu vou proceder agora ao registro de solicitação para intervenção. Se for possível fazer em inglês, melhor, para poder facilitar a comunicação com ele. E vou pedir também que as intervenções sejam relativamente curtas para garantir que possa haver possivelmente mais pessoas também que possam participar. E tenho aqui o pedido de palavra do Manuel Roni, por favor.
Okay, good afternoon. Thank you, Giovanni. Thank you, Mr. Dr. Luis. Okay, the presentation was very clear. And as we see, the containers is the way. But my question is, in terms of practice, Giovanni, what is the best way to implement the containers in terms of operating system? Should be on the Unix based or Microsoft?
Absolutely.
Or
Okay.
doesn't matter?
Yeah. So first of all, thank you. And so for sure, Unix, actually Linux-based systems, because containers are a technology that was born in the Linux environment. There are some efforts to run containers natively on Windows, but mainly the technology, if you want to be updated to if you want to keep the pace with the market, my suggestion is for sure go to Linux machines. This could be virtual machines or hardware machines. That is another kind of decision. It really depends on the type of the project, the budget that you have. Maybe you have already some machines that you can use. But for sure, if we consider only operating systems, for sure you should go with Linux-based systems. For example, I have a Mac, and what I do is to actually, if you install, for example, Docker on a Mac machine, macOS machine, what it happens is that you have a virtual machine with Linux, and inside Linux you have Docker. And because it's much better to use Linux, since it's a technology that was born in Linux and uses Linux-related features for being implemented.
Yes, sure. I have another one.
Sure.
May I?
Sure.
Okay. In terms of environment, if I migrate my whole infrastructure for the cloud or to be a serverless,
Okay.
What is your advice in terms of connectivity? Because in our environment, the connectivity is still a big issue. What is your comment in terms of that?
So I'm trying to think about the core of your question. So you are asking, because of course, if you migrate to the cloud, when the software is in the cloud, then users, depends on where your users are based, but if the users are all around the world, for example, then if you have low connectivity, there is no problem because your application is in the cloud. and user can access them. There could be at least two problems for low connectivity. First, in managing the cloud, because if you have a poor connectivity, is not that easy to manage and migrate the whole software. And the second one is to if the users are based in a low connected area, then migrating to the cloud is not that could not be the best solution, because if they can't reach the cloud, well, they cannot reach the application. An in-between solution is edge computing. So maybe you are not connected to the, you are not well connected to the internet, but, and I know that is a big but if you have a local, let's say, infrastructure in your area, then you can deploy your applications using one of the tools that I mentioned, for example, Kubernetes, in this infrastructure, and use it with these local, in these local infrastructures. Of course, it depends really on the deployment and the infrastructure that you have available. There is no easy solution. If you have low connectivity to the internet, it's not that easy to address this problem.
Can I add a comment here?
Yeah, sure.
Well, if you want, I know that we are, let's say, cloud oriented, but if you want, you can also run containers on your machine or on a physical server by you. And in this case, I think that the connectivity issue would disappear.
Oh, okay. Okay. Yes. Thank you.
Yeah. That's true. The machine should be reachable by the users, of course. So they should be, because if the local machines are still connected to the internet for being accessed by user, then you have the same problem. But if user can connect directly to your machines in some ways, then as Luciano was telling, then it's much better. And as I tried to explain, and it was a good point by Luciano, containers are very flexible and they allow different kind of deployment in local environments, in private clouds, for example, and also in public clouds.
Okay, thanks.
Manuel.
I'm clear.
Yes, thank you, Manuel, and also thank you, Luciano, by adding some additional inputs on this. I'm just seeing now the hand raised from Amarildo, please.
Please.
Thank you, Dr. Neves. Thank you, Giovanni, for the presentation. It was quite interesting and clear. Well, my first question was about your last slide, which you did not present, which was about the future, or what's the current research direction within this domain? What's interesting out there that we might want to pursue within this area? That would be my first question, but I have 3 questions. So I'll start with this.
Yes, please. Let's do it one by one because I don't have a good memory. So here I had just a few slides. I won't go into the details, but yes, for me, containers were really interesting also from a research standpoint, because it's not just a new technology, it's not just a new implementation, but we, together with Luciano and his advisoring, we thought that containers were an enabler for new approaches or for better approaches. And in particular, we tackled the problem of resource allocation or dynamic resource management. So the idea is that with, let's say, without any dynamic and or automated way to allocate resources, then you have an amount of machines and you can find yourself in 3 scenarios. First one, the optimal one, where the workload, so the amount of requests, matches exactly the amount of resources that you have. So that is the best scenario for this static case. But if requests are too much, then you are under provisioned, meaning that you need more resources, but you are not allocating them. And this means unreachability, for example, of the application. Or if requests are lower than this, the resources that you have are more than the requests that are incoming in your system, well, you are over provisioned, meaning that you are using more resources compared to what is really needed. So this is a lack of efficiency. And ideally what you want to have is to have an allocation that precisely follow the workload, so that in each moment of time, the amount of resources that you allocate matches the request incoming in the system. These approaches were well known when I started my PhD some years ago, but they were based on virtual machines. And since virtual machines, as I said, are quite slow to boot, for example, you cannot really precisely match the workload, because if you have a peak, very strong peak of request in a short period of time, say 1 minute, then even if you want to start a new virtual machine, you can't, because it takes too much time to boot. And so previous work were based on virtual machines with larger control period, and also they were using heavy weighted techniques for reasoning, so for calculating the exact amount of resources that was required to match the amount of requests with the resources. So our idea was to combine two lightweight enablers: containers for fast actuation, precise actuation, and better resource utilization, and lightweight control theory planners. So we used logics that are extremely fast in computing the next state. So these kind of logics were also available in the past before our work. But since virtual machines were slow to boot and could take 6 minutes, 5 minutes, 4 minutes, then even if these logics could take few milliseconds to compute the next state of the system, then you have a very fast engine, but you don't have the wheels for making the car go fast. And we thought that combining these two very different enablers, one is a technology and the other is a well-known theory, we could create a better system. And in fact, we mainly target 4 areas. First was, let's say, microservices, interactive cloud applications. Then we moved to big data batch applications. So we dynamically allocate resources for these kind of complex applications. Then we covered GPU accelerated applications. So application, for example, machine learning applications that can run on GPU accelerated hardware. So you have to control not only CPUs, but also GPUs. And finally, edge applications and that are deployed on function as a service, with an approach that is called Neptune that was recently accepted in SIMS. And I think here in the audience, we have another author of this paper, Luca Terracciano, along with Luciano, of course. So these were the 4 areas that we covered. And honestly, we think that we did a lot on this topic. And therefore, we started when basically containers were gaining traction, but weren't really popular. And right now we are moving, if I have to say one area is federated machine learning. That is this idea of decentralizing the computation of the training of machine learning models. And for doing so, you can use containers and control containers. So this is one topic, and the others are, in my opinion, at least refinements of these techniques. Of course, you can use containers with, instead of control theory, machine learning. You can do multiple things, but we explore the topic while quite well, in our opinion. And another point of interest could be unikernels, as I said. Unikernels are a new technology, quite new technology, that combines, just to simplify a bit, virtual machines and container, providing the same isolation of virtual machine with the lightweight style packaging of containers. I'm not sure, honestly, that doing the same work with unikernels or similar work with unikernels instead of containers is really a strong contribution, because the key idea here is having a fast technology that allows to quickly control the applications. That's at least my view.
Thank you for sharing this. It did seem, based on the presentation, that this idea of dynamically allocating resources was already a reality within the cloud computing providers. Is this something that they already, because I know that they have things like auto-scaling, which is maybe just giving you more resources, but not necessarily, I mean, auto-scaling is based on, how do you say, the workload that is being demanded from the applications that are being managed in that infrastructure. Is it something that is still, say, to be implemented, or is it already a reality?
It's already a reality. It was already a reality when we started, but cloud providers, when we started, didn't have container-based services, and they were providing auto-scaling system for virtual machines, so slow auto-scaling systems. Yeah. And moreover, they were using, at least when we started, rule-based approaches with rules written by the users. This, in our opinion, was not optimal because users often cannot a priori know how the system behaves, what's the best rule for all the cases. It's not easy. It's a good approach. So we improved, in my opinion, in these two ways, providing a faster way with containers combined with the other enabled control theory that provides more automations. Of course, in the last few years, cloud providers adopted, as I explained, a lot containers, and they also evolved the auto-scaling logics. For example, they employ sometimes machine learning for prediction, for workload prediction, or techniques that are not really control theory, but similar. So for sure, the competition from the industry is very high. But still, I think that our approaches are at least, I mean, we demonstrated with experiments that you can find in our papers that we improved the performance of the auto-scaling of the provided by cloud approaches. But as I said, the cloud providers are bringing more and more automation. And if you think about it, serverless make these approaches more difficult to be employed, because serverless means that everything is controlled by the cloud provider. So if we really want to do something, is to create algorithms for the cloud providers and not for the user of the application, as we did before, because we don't have control on the resources of serverless. So for example, in Neptune, we created our serverless approach, of course, starting from open source software with our custom control algorithms.
Right. I have two more questions, but I'll give space to Carlos, and if we have time, I would like to ask them.
Thank you for the interesting question.
Yeah, thank you. Allow me to congratulate you, Mr. Giovanni. So I would like to speak in Portuguese, so to avoid struggle.
Sure.
Ok, thank you. É o seguinte, a minha questão tem a ver com a orquestração de containers, né? Nós nos sentimos confortáveis em trabalhar com containers, mas o grande problema, por exemplo, parando para a nossa realidade aqui em Moçambique, é que não se recomenda a implementação
Alô, Carlos.
Yeah?
Alô, Carlos.
Sim.
Vai fazer a sua pergunta em português. Eu vinha que se fosse mais curta possível para facilitar a tradução, né? Porque ele não percebe português. Então, eu creio que o seu inglês é suficientemente bom para ele poder perceber qual é a pergunta que está sendo feita. Então, eu iria sugerir que fizesse mesmo em inglês, se não se importar. Pode ser?
Ok.
Yeah. Obrigado.
Mr. Giovanni, I was a bit struggling here, but I'll go on. My question is about container orchestration. Okay. So, in other workshop, they say it's not recommendable to root tech implementation is not recommended for container orchestration. So what I ask here, you see, as here in Mozambique, let me see if I can allow me to ask in Portuguese. So I will be direct.
Ok, eu creio que pode fazer em português.
Orquestração é de ser muito direto. Orquestração de containers. Recomenda-se trabalhar com provedores provedores de nuvens, mas nós temos restrições legais. E como é que podemos ultrapassar isso aí? Porque não se recomenda implementar um orquestrador, um sistema orquestrador de raiz. Recomenda-se a ir para um provedor cloud como a AWS e outros. Então é nessa vertente que queria que ele respondesse alguma coisa. Muito obrigado.
Okay, Giovanni, did you get the question?
Actually, I heard just, no, if you can translate, please.
Yeah, he was, from what I understood, he said that from other workshop was not recommended to do this container orchestration. Mm-hmm. And is mostly advised or recommended to use cloud-based providers as AWS. Mm-hmm. I hope I translated properly.
Can I help?
Yes, please.
Yeah. He was also saying, apart from what Dr. Luis said, that in Mozambique, particularly, we have some constraints, some limitations by law that we should not use these cloud providers. But in the same time, it is not advised, it's not recommended to build your own infrastructure or orchestration.
Well, I didn't know about these law or legal limitations, but the cool thing of Kubernetes is that that is the most popular container orchestrator, is that it's open source. You can download it, you can use it freely, you can even extend it without touching the core parts. So my suggestion would be to use, of course, you should not create your own orchestrator. That is really difficult to do. And I also agree with this other workshop to not employ this kind of effort. But I would advise to use let's say, deployment of Kubernetes onto a private, let's say, infrastructure. I say Kubernetes because it's the most used one and the most, in my opinion, as a practitioner, let's say as a user, it's the most powerful, but there are other approaches such as Docker Swarm or Marathon and others. But if I have to say one, I will say Kubernetes. And of course, as I said, you can simply install it on your machine quite easily. So this is my suggestion. And the cool thing is that, I will say hopefully, that the law changes, then to migrate to a cloud provider, it's very easy, because if you already use Kubernetes in your private cloud or in your private infrastructure, you can then use Kubernetes as a service from a cloud provider and use the same tools, the same software, the same configuration that you used in your private infrastructure in the cloud. There won't be any difference, because all the cloud providers provide, sorry for the play of words, but provide Kubernetes as a service. And this cannot be said for other orchestrators. This is another point for Kubernetes compared to the others.
Could I build on that question?
Yeah, sure.
So if you decide that you're going to use, for example, Kubernetes on your private
yes,
data center,
yes,
you're going to implement this. In terms of skills required to move into this way of working, is there anything? Do you need how do you say? Do you need specific skills? Let me give maybe a clear example. We were talking before that one of the core components of the container working containers is having images, for example. These images need to be developed. Is that like just normal kind of development, or is that requiring very like expertise in that?
Well, the fact that you attended this workshop, it's already one point, no, apart from the jokes. I mean, these tools, for example, to create images, going to the details, creating images is quite straightforward. You have dedicated languages that are very, very simple to list basically and install in a container images all the files, all the libraries that you require for executions. So the skill that you really need is like a bit of Linux system admin skills. So you need to know some commands from the command line for being able to write these container image file. For example, in Docker, they are called Docker files, or in other standards, container files. But in general, if you are able to deploy your application outside container, then you will be able to deploy your application also with container. There is not huge step in using container, at least in my opinion. For using Kubernetes, Kubernetes is a very big tool. It's complex, but it's really well defined. So using Kubernetes requires a bit of study. You can start by the public documentation of Kubernetes. This is a very good starting point. Just to understand what are the concepts, what are the abstractions used by Kubernetes. This is a bit of step, learning gap. But I will not say that you need a specific skill. If you operated in the cloud before, if you are a programmer, if you have a bit of experience in using a Linux operating system, you won't have a lot of problems. So just to recap, in my opinion, just to use containers in your local machine is quite easy. For using an orchestrator, you need a bit of, let's say, study. but not a specific skill. If you are able, as I said, to deploy your application in another environment, you will be able also to deploy the same application in Kubernetes.
Yeah, thank you. I think I was a little bit unfortunate in my wording of the question, but I think you covered. My concern was mostly on the orchestration side of things, less.
Okay. Yeah.
The containers, because I have worked a little bit with containers, but not much in terms of Kubernetes type of tools.
Well, it's already a good starting point, because if you are familiar with containers, let's say the container technology, then you are already at, let's say, a good point. As I said, Kubernetes, because it's so modular, you need to understand a bit how it works. It's not immediate, but I won't say that is difficult. So you need to study a bit the building blocks of Kubernetes, the concepts that are concepts called controllers. You have to understand what is a pod, what is a volume, and so on. But it's a deployment, a service, but it's not that difficult. And in terms of skills, I think that if you were able to use containers, you have all the skills to also use Kubernetes, apart a bit of technological gap that you have to cover.
Right. Last thing I have is a curiosity about functions as a service.
Okay.
Could you provide maybe use cases, examples of use cases where functions as a service would be preferable to something else, to application as a service in this case, as you put it, and also maybe comment in terms of software engineering, when you are designing your system, if this would be a thing that you should consider doing at an early stage, or you should maybe only start thinking about this later on, because it seems, of course, loosely coupled components are nice, because you have things isolated, but then also they become complex. Too many things to manage also.
Well, that's a very complex question. My idea is that serverless is an enabler for new applications to be developed. That's for sure. That's a very easy use case. For applications, for example, that need a very fast time to market. So, for example, you have the best cool idea, and you want to and you want to share your idea with the market, with the audience, with the public, in the shortest time possible. The best technology is serverless, because with serverless, you write the code and it's online. You don't have any management, you don't have any operation, at least on the back end. And usually when you start creating a service, an application, the application is not that complex. Another thing is to ask if the serverless paradigm is sustainable when the application becomes bigger and bigger. I don't have a strong opinion on that. In what I can see, my intuition is that in the end, if you become large or very large, you want to go for serverless because you rely too much on a cloud provider. And then it will be very difficult to move. And the costs are not, if you are very, very, very big, you have a lot of workload all the day. So in those cases, you are more structured because you are big, then you can afford to have operations. And already containers, as I explained, allow for a strong automation, for a strong flexibility and reduce a bit the effort in operations. So in my opinion, at the moment, at least, when the things should become more complex, I agree that let's say a microservice architecture running on Kubernetes, for example, is better than function as a service. But also, it must be noted that they are not two opposite words. You can have some parts of your applications on serverless and other parts in Kubernetes. They are completely compatible, Kubernetes or other types of infrastructures. So they are not two separated words. You can have, for example, event-based computation, you can have serverless. For things that you have to optimize with a lot of efficiency and cost reduction, then maybe it's better to go for a custom infrastructure and architecture.
Thank you for comprehensive answer.
Thank you, Amarildo, and also to others who already presented some comments and questions. Also, I think we are now going to the end. I don't see any requests for intervention. In that sense, maybe before we close, Giovanni, I don't know if you have any last word for this session.
Yes. No. Yes, I have. Wait a second, because I no. Oops. Sorry about that. Let me. Grata pela atenção.
Oh, that's good starting, you know. Ok. Ok. Muito obrigado a todos por participarem, não é? E terem algum tempo para poderem fazer parte dessas sessões. Essas são sessões, those kind of sessions we'll have in near future. We still have more sessions to have, and we'll share with you. And we also expect to have a presentation from teachers from the university, Eduardo Mondlane University, Faculty of Science and Faculty of Engineering, under this ICT for Dev project in collaboration with Politecnico de Milão. That's why we have Dr. Giovanni now in this talk. And yeah, thank you for Polini and Professor Baresi and other colleagues from UAM who are part of this process, and see you soon. Até breve. Muito obrigado.
Thank you very much.
Yeah.
Thank you.
It's a pleasure.
Obrigado. Obrigado a todos.
Thank you.